I have a big news for you in this video, so watch the video till the end. One of the most time-consuming process in microeconomics is the utility maximization. Mostly if we have a problem set related to the utility maximization, so it takes a long process until we maximize the utility and we find out the value of our x and y in utility function. But maybe most of the students will think about that. Is there any easiest way or any shortcut way to maximize our utility? Yes, there is. So let me tell you how we can find out an easy way, in a shortcut way, and least time consuming to find out the utility maximization bundle. And what's that? So it's very important to know this shortcut way in order to economize our time during the exam. Otherwise, it takes a lot of time to solve one problem related to utility maximization. So without any other talk, so let's jump into it. So first of all, let me tell you that we have different types of utility function, and the same process does not work for every utility function. So we have a different process for different types of utility function. So first of all, let me tell you that we can divide our utility function in three types. The first one, which those utility function which they are two-wise differentiable, like Cobb-Douglas utility function, CS utility function, or quadratic utility function, but even quasi-linear utility function, which is two-wise differentiable on nonlinear good. And also, we have perfect substitute utility function, which is not two-wise differentiable. Rather, our perfect substitute, which is a just linear utility function, is just one-wise or one-time differentiable. And also, we have utility function, which is perfect complement utility function, which is not differentiable. So we have utility function which are two-wise differentiable, which is just one times differentiable, and utility function which is not differentiable. So we have different process for each of them. So let's go into it and find out what is the easiest and shortcut way for maximizing utility function related to each type of this utility maximization process. First of all, let me talk about two-wise differentiable utility function, which is one of the most time-consuming utility maximization process. So if we have a utility function like Cobb-Douglas, CS, quadratic, or even quasi-linear utility function, which they are two-wise differentiable, so what will be the process, the shortcut way? For example, if we have a utility function, a Cobb-Douglas utility function, which is a function of x and y is equal to x to the power of alpha, y to the power of 1 over of alpha, y to the power of 1 minus alpha. So first of all, we need to do the two process. The first process is to set up the optimization condition. The first process is to set up the optimization condition. What is that optimization condition? The optimization condition is marginal rate of substitution is equal to economic rate of substitution. We should set up this optimization condition. So what is the marginal rate of substitution? The marginal rate of substitution is equal to the marginal utility of x, if we have this function, divided by the marginal utility of y. And what is the economic rate of substitution? Economic rate of substitution is the ratio of prices, which is equal to px divided by py. So this is the first step. The first step is to set up the optimization condition. Then what we are going to do, so when we set up this optimization condition, now find out either the value of x in terms of or as a function of y, or in another way, find out the value of y in terms of x or as a function of x. Then the second process is to have our budget constraint, which is equal to px multiplied by x plus py multiplied by y is equal to m. So either you find out the value of x or the value of y in terms of another bundle here, then substitute that value to this budget constraint. For example, if you find out x in terms of y, so then instead of x in this budget constraint, plug the value in terms of y, then we will have only y and y in this budget constraint. Then it's easy to find out either x or y, the value of x or y from this budget constraint. Next, again, come back. When you find out x or y from this budget constraint, when you plug in the value of either x or y to this budget constraint, then for example, if you find out the value of x, then what will we do next? Just substitute again the value of x to the results of this utility optimization process. Then we will find out both x and y. So in the next video, I will solve some questions, especially related to Cobb-Douglas and utility functions. So keep watching the next videos as well in order to know with example. So it's just a simple introduction. So let's move out. So A is just simple as this. Then if you find out the value of x, then plug in the value of x to this equality that we find out here from setting up the optimization condition, then we will find out the value of y as well. The value of y as well. So now, let's move out to the second type of utility function, which is like just one-time differentiable, which is like an example of perfect substitute. If you have a utility function of perfect substitute, which is just x plus by, so what will be the optimization process? We have, again, two steps. The first step is to find out the marginal utility per dollar of x and the marginal utility per dollar of y. So then marginal utility of x divided by px is called the marginal utility per dollar of x. And also the marginal utility of y divided by the price of y is called the marginal utility per dollar of y. So if we find out this one, the second step is to compare the marginal utility per dollar of x with the marginal utility per dollar of y. So what will be the solution? So if the marginal utility per dollar of x is greater than the marginal utility per dollar of y, so what we will do, we consume only x. We allocate all our budget on consuming x. If in another way, if the marginal utility per dollar of y is greater than the marginal utility per dollar of x, and this time we consume only y. So we maximize our utility by consuming only y. But when the marginal utility per dollar of x is equal to the marginal utility per dollar of y, there's equality sign, so we will consume any combination of x and y. It depends on our own preference, any combination of x and y. So this is how we can find out the utility maximization bundle when we have like a perfect substitute utility function. And the third one, if we have a non-differentiable utility function, which is like perfect complement utility function, which is a mean function. The utility function is equal to the mean of ax by. So again, we have two steps. The first step is to equalize ax and by, because we are going to minimize our utility. And the amount or the level of utility that we get from ax is equal to by. Why? Because they provide similar utility, because they are perfect complement. Then the next step to again set up our budget constraint. Set up our budget constraint. So it's very easy. So we don't need any differentiation, any derivative, any like Lagrangian process here. So what will we do here? From this setup that we have, for example, either find x in terms of y or y in terms of x. For example, let's find out x in terms of y. X is equal to b divided by a y. So it's just simply, this is the value of x in terms of y. Then plug this value instead of x in this budget constraint. So then we only have y as a variable here, then easily we can find out y as a function of p and m. As a function of p and m. So what will be the next process? If we find out y as a function of p and m, then we will have like our y star. Then plug the value of y star instead of y to this equality. Then we will find out our x star. It's as easy as it is. So this is the shortcut way in order to do the utility maximization process for three types of utility function: two-wise differentiable, just one-time differentiable, and non-differentiable utility function. I hope it helps you in order to maximize your utility when you have different types of utility function. In the next video, I will solve clearly different types of utility function for each one of them in order to know in details how to do this shortcut or like easy process in order to maximize our utility function. So keep watching my YouTube videos and see you in the next video in order to solve different types of utility maximization process and economize our time during the class exam. Thank you so much for watching. See you in the next video.